in the points that are on the x positive and negative x-axis, the positive and negative y-axis. Those were simple because it makes sense. If the radius of this circle is 1, then this point out here has an x coordinate of 1, a y coordinate of 0, and etc. going around the circle there. All right. Then we started filling out the first segment here in each quadrant. So we start right here at 0, and if we go 30 degrees, that's where we end up on this first part of the unit circle here. 30 degrees is equivalent to pi over 6 radians. And the coordinate of this point out here is the square root of 3 over 2, 1/2. Now here's the whole purpose of the unit circle. I didn't get to this part yesterday because I wanted to just get started on it. But I told you that the x-coordinate was the cosine of the angle and the y-coordinate was the sine of the angle. So if on my calculator I type in, let's see which mode I'm in radian mode. So if I type in the cosine of pi over 6, then it's going to spit out this decimal value to me, okay? Well, if they ask you on the final exam, what's the cosine of pi over 6, they're not going to give you that decimal. What they're going to give you is they're going to give you the square root of 3 over 2. So if you have a question about which one it is, then you just type in the square root of 3 over 2 in your calculator, and you compare the decimal values there, and then you can select the right answer. Just notice that you've got to close the parentheses after the 3 right there. Okay, you have to close the parentheses after the 3 before you divide by 2, or it's not going to give you the right number. Okay, if you just type in square root 3 divided by 2 with no parentheses, that's not the right value. Okay, that's not the right value. And if I type in the sine of pi over 6, then it's going to give me 0.5 or 1/2. Okay, so that one's easy. But when the square root's involved, it's not quite so easy, all right? So that's what the unit circle is telling us, is it's giving us these values in exact square root form instead of what our calculator would give us in decimal form. Okay, let's go to the next segment, the middle segment right there in the first quadrant. If it is right in the middle of the first quadrant, can anybody tell me what angle measure that would be if it's right in the middle? If we've got 0 here and 90 here, then what's right in the middle? 45. Okay, this is 45 degrees right here, and it is pi over 4 radians. Now this one's really easy, okay, because it is the same x and the same y, because it's right in the middle. The x-coordinate and the y-coordinate are exactly the same, and they are the square root of 2 divided by 2 and the square root of 2 divided by 2. Again, if I were to type that into my calculator, let me put it in degree mode to show you that it doesn't matter, just so that we're in the correct mode. So the cosine of 45 is 0.707 approximately. So if I type in the square root of 2 divided by 2, guess what it is? 0.707. Okay, so if we go to the same point in the second quadrant, if we just go directly across, we are 45 degrees away from 180, so we're at 135, and we are at 3 pi over 4 is 135 degrees in radians. Okay, that's 135 degrees in radians. So we're going to have the same x and y coordinates, but in the second quadrant, our x values are negative. Our x values are negative in the second quadrant. So exact same point, square root 2 over 2, square root 2 over 2, but the x values are negative. Okay, in the third quadrant, if we go directly below this, we are at 225 degrees. And this is 5 pi over 4 in radians. Okay, 225 degrees, 5 pi over 4 in radians. It's the exact same point, except x is negative and y is negative. X is negative and y is negative. Okay, in the fourth quadrant, we are 45 degrees short of 360 degrees, so we're at 315 degrees. And this one is 7 pi over 4 radians. In the fourth quadrant, our x coordinates are positive, our y coordinates are negative. All right, so we've got one more angle in each quadrant that we need to label. Let's look in the first quadrant. If we've got 30 degrees, 45 degrees, anybody want to give a guess as to what that third angle is going to be?
90.
Well, we've already got 90. 60. Okay, it is 60. It is completely symmetric. It's 15 degrees between each of these angles here. So we've got 60 degrees, and that is pi over 3. Okay, 60 degrees is equivalent to pi over 3 radians. When we multiply by pi over 180, 60 over 180 is 1/3. Okay, and the cool thing about this is it just switches the coordinates of the 30 degrees. Okay, so the same numbers as the 30-degree point, but it switches the x and the y. Okay, so it's 1/2 square root 3 over 2. Okay, if we find this angle in the second quadrant, it's 120 degrees, and it is 2 pi over 3 in radians. So it has the same coordinates except the x is negative. So it's negative 1/2 positive square root 3 over 2. Negative 1/2 positive square root 3 over 2. Okay, in the third quadrant, we are at 240 degrees, and we are at 4 pi over 3. And this would be negative 1/2 negative square root 3 over 2. And I don't know if I emphasized this yesterday, but notice how my fraction bar right there is written, okay? It's not just under the 3. It's under the entire square root, okay? It is the square root of 3 divided by 2. It's not the square root of 3 divided by 2. It's not the square root of 1.5, okay? And then our last angle over here is 300 degrees, or totally blanked on it. 5 pi over 3. 5 pi over 3. And this is going to be positive 1/2 negative square root 3 over 2. Because our x coordinates are positive, our y coordinates are negative. Okay, so y'all know me. Y'all know that I don't normally make a copy that only has something on one side of the piece of paper. I did in this case because you're going to have to use this. I don't want you to have to keep flipping the paper over to be able to do the problems on the back, okay? So you need to keep this paper right beside the other paper that I just passed out to you, okay? Because we're getting ready to use the unit circle, okay? We're going to use it. So we put all this information on it. It tells us things. We're going to look at what it tells us. So what it asks us to do is evaluate. Well, evaluate is a fancy word of, or a fancy way of saying find the value. Okay, find the value. Evaluate means find the value. So anytime a question asks you to evaluate, your answer is going to be a number. There aren't going to be any variables in it. It's going to be a number. Okay. All right, so the sine of 3 pi over 4. So what we need to do is we need to go to our unit circle. We need to find the angle 3 pi over 4. It's right here in the middle of the second quadrant. Okay, When we see sine, sine is the y coordinate. Okay, so we go 3 pi over 4, we go to the y coordinate of 3 pi over 4. So the answer to this is I'm going to write y right under sine, okay, just so that we're thinking about that. And this is equal to the square root of 2 over 2. Now, if you're doing this on a test or something and you don't have the unit circle with you and you have answer choices, you need to make sure, number one, you're in radian mode because 3 pi over 4 is radians. Type in the sine of 3 pi over 4, okay? But it's not going to give you the exact value, and that's what the answer choices are going to look like. So then you just need to compare the decimal values of the answer choices. So the square root of 2 over 2 is approximately 0.707, which is what your calculator is going to tell you the sine of 3 pi over 4 is. Okay? But the answer I want is the square root that's off the unit circle. Okay? All right, so let's keep going. Cosine of pi over 3. So cosine is the x coordinate. Okay, cosine is x. So we find pi over 3. It's in the first quadrant right here. The x coordinate at pi over 3 is 1/2. All right, the cosine of 90 degrees. Okay, cosine is again the x. 90 degrees is right here. The x coordinate is 0. So on some of these, you can just use your calculator. Your calculator will give you the correct value as long as you're in the correct mode. If your angle is radians, you got to be in radian mode. If your angle is in degrees, you got to be in degree mode. All right. So as long as it doesn't have a square root in it, your calculator will tell you the answer. All right, D, the sine is y of 540 degrees. Now, is 540 degrees on our unit circle? No, it's not, okay? 540 degrees is more than 360 degrees, okay? So what has happened, and let me go over here to my unit circle to show you. We have started right here. We've gone all the way around 360 degrees, and we've kept going. Okay, we've kept going. So how can we figure out how far we've kept going? Good. 540 minus 360. That's perfect. Okay, that's how much further that we have gone than just one rotation around the circle. So we've gone 180 degrees past where we started. So it's the same thing. Okay, so I'm going to mark out the 540 and I'm going to put 180 there in its place, because they're the same angle. It just means I've gone all the way around my circle and I've kept going. All right, so the sine, the y coordinate of 180 degrees is 0. Okay, let's keep going. The sine of 7 pi over 6. Okay, 7 pi over 6 is down here in the third quadrant. Sine is the y coordinate, so that is negative 1/2. Cosine is the x. 7 pi over 4. 7 pi over 4 is in the fourth quadrant. The x coordinate is square root 2 over 2. Okay, and then the last one, G, we've got the sine, which is y, of 215 degrees. Is 215 degrees on our unit circle? No, we got 210, we got 225. So guess what? If they ask you something about an angle that's not on the unit circle, you have to use your calculator. Okay, you have to use your calculator. So this is degrees. So you have to change the mode to degree mode, or it will not give you the right answer. Okay, the sine of 215 is approximately negative 0.574. This is the only time it's okay to put a decimal value, is when they ask you an angle that's not on the unit circle. Okay, if they ask you an angle that's not on the unit circle, it's the only time that it's okay to have a decimal answer. Let me show you what would have happened if you didn't change your mode. Okay, if you were in radian mode and you typed in the sine of 215, it gives you a very different answer. It gives you 0.98. Okay, that is very wrong. because that's 215 radians. 215 radians is very different from 215 degrees. Okay, so the reason why you have to change the mode in the calculator is because we don't put a symbol here with our answer. Okay, we don't put a symbol there with the angle that we're plugging in. So the mode of the calculator is telling your calculator how to interpret that number. Do I read that number as degrees, or do I read that number as radians? That's why you have to change the mode if you're using the calculator. But the good news is, what I'm getting ready to ask you to do, they're all going to come off the unit circle. Okay, they're all going to come off the unit circle. You really don't need to use your calculator. Okay, but before we get to that, let's do one more thing. Flip your paper over. Okay, they may ask you a question like this. Find the angle in radians that corresponds to the given point on the unit circle. Okay, find the angle in radians that corresponds to the given point on the unit circle. So instead of just looking all over our unit circle for the point positive square root 2 over 2, negative square root 2 over 2, let's narrow things down just a little bit. If my x coordinate is positive and my y coordinate is negative, which quadrant should I be looking at? Positive x, negative y. Which quadrant? We got 1, 2, 3, 4. 4. Okay, this is in quadrant 4. So that just kind of narrows down. You don't have to go searching all over your unit circle. And in case you've forgotten how the quadrants are numbered, I should have gone over that to begin with. This is quadrant 1, this is quadrant 2, it's counterclockwise, 3, and 4. Okay, so we're looking, yes. Yes, just like the regular graph. It's quadrant 1, 2, 3, 4. Yeah. Okay. Oh, up. Okay. So we are looking for the point. We know it's in quadrant 4, and it has coordinates positive square root 2 over 2, negative square root 2 over 2. We want the answer in radians. So that is the angle 7 pi over 4. Okay, that is the angle 7 pi over 4. So I'm going to say theta. Theta is usually what we use to stand for an angle, equals 7 pi over 4. Okay, example B, the square root of 3 over 2, 1/2. Positive x, positive y. Which quadrant are we in? Quadrant 1. Okay, the first quadrant is the only one where everything's positive. So let's look for where the x-coordinate is square root 3 over 2 and the y-coordinate's 1/2. That's right here at our first angle in radians. That is pi over 6. So theta equals pi over 6. Now, you don't necessarily have to locate the quadrant first. Okay, you don't have to locate the quadrant first. It just saves you a little bit of time. You don't have to go looking all over the entire unit circle. If you take just a second to think, okay, positive x, negative y, that means I'm down here in the fourth quadrant. You have a lot fewer choices to choose from there. Okay? All right, so let's look at the other two examples here on this page. Identify all angles in radians and degrees where the cosine is equal to 1/2. So let's do the same thing. Let's think about this. Cosine is the x-coordinate. Okay, x values are positive in quadrant 1 and quadrant 4. Okay, x values are positive in quadrant 1 and quadrant 4. So let's look for where we have an x of 1/2, positive 1/2. Okay, that's at 60 degrees or pi over 3. And it's at 300 degrees or 5 pi over 3. So that is our answer here. Theta equals 60 degrees or 300 degrees. And I'm also going to list it in radians. Pi over 3 or 5 pi over 3. All right. So 4 answers, but technically 2 of them are the same. 60 degrees and pi over 3 are the same angle, just one's in degrees, one's in radians. All right, let's look at D. The sine of theta, sine is the y-coordinate, is -1/2. Y-coordinates are negative down below on the bottom, so that is quadrant 3 and quadrant 4. So in quadrant 3 and quadrant 4, let's look for where the y-coordinate is -1/2. So that's at 210 or 7 pi over 6, and it's also over here at 330 or 11 pi over 6. So theta is 210 or 330, and theta is 7 pi over 6 or 11 pi over 6.